Thank you for watching my video. My name is Mr. Charles Wenike. In this video tutorial, we will discuss on a capacitor this is a video that contains or that will be talking on a capacitor. It is a capacitor series. Therefore, in this video, we will like to find out what capacitor is all about, how does it work, what are the types of capacitor, and the other important capacitor function as well. In this video tutorial as well, we have other topics to treat, but it will be in the next videos that I will also produce. So in that case, let's start with what is a capacitor. A capacitor is also known as condenser. Back in the days, I know capacitor as it was, or it is called, a parallel condenser plate. You can also call it a condenser. Presently, it is called a capacitor. Capacitor generally used to store charge. It is also generally used to store charge. In capacitor, the charge is stored in the form of electric field. In capacitor, the charge is stored in the form of electric field. And also, don't forget that capacitor is one of the passive components, which I have already treated types of components. I discussed on passive and active components. If you have not watched that video, please go to my YouTube channel, Charles Electronics, watch on passive and active components, the key differences and how they function. Now we discuss types of capacitor. There are two types of capacitors. One is alternating current capacitor and the other one is direct current capacitor. Now, how can we differentiate these two capacitors? They all work the same thing, but one is for AC, being alternating current, while the other one is for DC, being direct current. Now, how can we differentiate these two? Now, we can differentiate these two by knowing the difference between alternating current and direct current. Direct current is a current that can be converted from AC to DC, while an alternating current is a pure current that has not been converted. And what can be converted? What is that component that we use to convert AC to DC is called a diode. A component that we use in converting alternating current to DC current, it is called a diode. We will discuss diodes as well. We will discuss resistors and every other component as well. So in this particular tutorial, we are discussing of capacitors. So what brought the issue of diode? The issue of diode is I use diode to differentiate the alternating current and direct current. I said that we can use diodes to convert AC current to DC current. Why this alternating current is a pure current, it won't be converted to anything. It remains the way it is. For instance, let's say we use generator. Once we power, it could be a generator, it could be a lister. Once we power our lister and we want to watch a television, do you know that in that television there are other components that makes up of that television? We have fuse, we have diode, we have resistor, capacitor, and so on and so forth. So the work of that diode there is to convert the AC current to DC current. If not, every other component there that uses DC current will be damaged if the AC current straight to it the component will be destroyed. So that is why I use diode to convert. That is why we use diode to convert AC to DC. So in that case, let's look into alternating current capacitor pictures or images. You can call it pictures, you can also call it images as well. Here we have in this capacitor, this is all this that you're seeing on this screen is called AC capacitor, being alternating current capacitor. Now this one you can see it in AC. For instance, in AC we use AC that we use in our various offices. This one is also there. Without this, it means that the AC will be on, but that is the AC will not function effectively. Mostly this one we normally see it in our ceiling fan as well as standing fan. It's also an AC capacitor. Remember, you cannot use this AC capacitor in the replacement of DC capacitor in any circuit. AC capacitor is meant for AC capacitor, while DC capacitor is also meant for DC capacitor. But in that case, there are a capacitor that work in between the AC and the DC. We will discuss those capacitor as well, and you will see the exact capacitor that work between the AC and the DC. Here, the same thing is applied. It's also an AC capacitor. You can also see it in lister in various areas, and they have a specific function. The same thing that DC function is the same thing that an alternating current capacitor function. They function the same thing, but they are all made in different areas. That is why we are all human beings, but we are not, we don't have the same function. We have in our different careers, we have people that study medicine, we have people that study engineer, and so on and so forth, but we are all human beings. So the same thing applies to capacitor as well. So in that case, this is DC capacitor as well. This one is surface mounted capacitor, which it is mostly or always used in laptop. While this one is electrolytic capacitor, we will discuss this as well. This one is tantalum capacitor, which comes from polarized capacitor. We will discuss each and every one of them. I am just giving you an introduction aspect of it. So in that case, all these capacitors are DC capacitor. You cannot use this in replacement of AC capacitor. It won't work. AC capacitor is meant for AC circuit, while DC capacitor is meant for DC circuit as well. So this is the capacitor diagram. This diagram, we will use this capacitor diagram to differentiate the fixed capacitors and the variable capacitors. In that case, in fixed capacitors, we have non-polarized capacitor, we have also polarized capacitor. In variable capacitors, we have tuning capacitors and trimmer capacitor as well. We will treat each and every one of these, each of them one by one, the variable capacitors and the phase capacitor. In that phase capacitor, we will treat this non-polarized differently, also treat polarized differently. Each of them will be treated one by one. Okay, let me explain more about that. Now, from what I said about this tantalum capacitor is a polarized capacitor. This one is also a polarized capacitor. If you watch on this surface mounted capacitor, it has positive and negative. That is to show you that it is also a polarized capacitor. So as time goes on, when I will discuss on polarized and non-polarized, you will also see the differences as well. So in that case, let's talk about types of fixed capacitors. There are different types of capacitors available in the market. For sure, there are different types of capacitor available in the market. The key factor in distinguish to separate or to differentiate type of capacitors type of capacitor is the dielectric used in its construction. The key factor in distinguishing different types of capacitor is dielectric used in its construction. I will discuss on this dielectric as well in the next video that I will treat. I will discuss dielectric materials and as well in capacitor and so on and so forth. I will discuss each and every one of them. If you follow me on this video, you will learn a lot based on capacitor, transistor, and any type of electronics component. You will learn a lot and know how to fix it. If you are to build a circuit, you know the actual component and how to prorate or calculate the voltage or the current that will enter it, so that you will not have an issue in reducing any electronics circuit. So in that case, the key factor in distinguishing or separating or differentiating different types of capacitor is the dielectric used in its construction. That is to know if the capacitor is polarized or non-polarized. The only way you can know is the dielectric used in constructing the capacitor. Now, some of these common capacitor types are ceramic. Ceramic is one of the non-polarized capacitor. Electrolytic capacitor is one of the polarized capacitor, which include aluminum capacitor, tantalum capacitor, the one that I just showed you before, and niobium capacitors as well. They are under polarized capacitor. Plastic film, paper, and mica, they are non-polarized capacitors. I promise you that you will see each and every one of them, the images or the picture. All this one that I have differentiated, this one, ceramic are what? Non-polarized. Plastic film, paper, and mica, they are non-polarized capacitor, while other ones, they are polarized capacitor. Each capacitor type has its own advantages and disadvantages. You know, in everything in life, they have advantage and disadvantage. So that is what you should bear in mind as well. The characteristics and area of application may vary from one application to other. That is, the characteristics and the areas of application, it might be different. But what I want you to understand that they function the same thing, just as I explained during AC and DC. The area of the application could be or might be different, but they function the same thing. That is why I use the characteristics and area of application might vary from one capacitor to another. That is what you should know. The capacitor used in AC being alternating current, which we used in our various homes. I gave you an example that our ceiling fan or standing fan use alternating current being AC capacitor. While you cannot use a DC capacitor to replace it, it won't work. That is how it is, because the DC capacitor is not meant in that circuit of AC capacitor. So that is why they are different in their area of application, but they function the same thing. Both the physical dimension and the value of the capacitance is important. The physical dimension and the value of the capacitance is important. What will determine the capacitance is the dielectric. Dielectric determines the name of the capacitor. Dielectric also determines the capacitance of the capacitor. It has a lot of work to do in terms of capacitor. So in that case, the physical dimension, it means how small or how big or how large or how anyhow it is that your eye can view it is also important. You know, in capacitor, it has various ranges. It has various ranges. It also have the one that you are maybe they are talking of the capacitance, the one that you can see 5 UF being 5 microfarad, 5 microfarad or 5 farad and so on and so forth. They are all different. Why it also has a number that we see 400 volts, 1000 volts, and so on and so forth. All those things, those names, those numbers are important in case if you are to replace. Now let's talk of or discuss on variable capacitors. Like resistors, capacitors are also available as fixed and variable type, just the way I show it from the capacitor diagram. Like resistors, capacitors are also available as fixed and variable capacitors and variable types. Variable capacitors are those in which the capacitance can be changed either mechanically or electronically, either in mechanical form or in electronic form. The two are different. It means that the capacitance can be changed. That is, the capacitance will determine the volume of current that it will contain. You know, there is a difference between a capacitance and the voltage that it will carry. At times, in terms of voltage, capacitance or capacitor will be very good in terms of voltage, but the capacitance that will withstand the voltage, once the capacitance is not sufficient enough to withstand the voltage, it means that that circuit or that capacitor is no longer in a good shape. So, which means that in variable capacitor, the capacitance can be changed either mechanically or in electronically. That is just how it is in terms of variable capacitor. Now, such capacitors are generally used in resonance circuit. Such capacitors are generally used in resonance circuit for tuning radios and impedance matching in antenna. You know, majority of our so-called radio, even our CD and so on and so forth, the way we tune, when we want to maybe tune to a particular channel and so on and so forth, always remember that there are impedance matching and as well as a capacitor that is doing that particular work. If the capacitor or whatever thing is not functionable, it's not good, you see that it will be having an issue. That is why in each of the electronic circuit diagram, we have different types of it. We have pictorial circuit, we have block diagram, we have and so on and so forth. Those are the things that you start from small stage to couple a circuit to an extent it will become a larger circuit. But when I will discuss that, before I go into the practical aspect of it, I will discuss the types of circuit. How do I put it? The diagram. When I will discuss that, before going into the practical main, we will discuss the three important circuit diagrams: the picture, the block diagram, and the pictorial diagram, and one of them as well. We will discuss it, and we will also discuss complex diagram, complex circuit diagram. We will discuss it. How comes about from 1, 2, 3 they combine and they form a large circuit that can make up of a motherboard or whatever thing. It's a gradual process. But before then, we must know each of the components, how they function, the temperature coefficient, and so on and so forth. So that is the most important thing that makes me to discuss or to be treating on this differently before going to the practical aspects. So in that case, these capacitors are usually called tuning capacitors. They are called tuning capacitors. You can, maybe if you are not an engineer, maybe you will not really get what I'm trying to explain here. But with this, what I have just said now, such capacitors are generally used in resonant circuits, right? LC, for tuning radios and impedance matching in antenna. Impedance matching in antenna, you know what, before your radio could or can get a signal, definitely there is an impedance matching in that particular circuit so that you can get any type of signal that you want it to get. It's the same thing in our television as well. The same thing in our handsets. In as long as it receives or it receives a radio station and so on and so forth, it has that a resonance circuit for tuning radios and impedance matching, and those capacitors are called tuning capacitors. There is another type of variable capacitor called trimmer capacitor. These are fixed on PCB. PCB, it simply means printed circuit board, and are used for calibration of the equipment. PCB is stand for printed circuit board and are used for calibration of the equipment. And you know that this trimmer capacitor is not too rampant, but depending on what you want to do. So that is another type of variable capacitor as well. They are non-polarized capacitors. Remember, they are non-polarized capacitors. Non-polarized capacitors are those capacitors that does not have negative or positive. They are just like that. You can see an indication of this one is positive, this one is negative. Why polarized capacitors are those ones that you can see positive sign and negative sign on it, and are very small in size. They are generally not available for the use of regular customers. The capacitance of variable capacitors is very small. The capacitance of variable capacitor is very small, which is usually in the order of few picofarads. I will also discuss of picofarad, nanofarad, and so on and so forth. That one will be discussed later as well. So generally less than 500 picofarad. That is how the variable capacitor, the one that I just mentioned, that is, they are less than 500 picofarad as well. So in that case, if you like my video, please subscribe to my channel, comment, and like. See you in the next class. Thank you once again.